So this video is the continuation of derivation of I will show you derivation of equation of motion of compound pendulum. So if you want to check out the previous steps if you want to check out the previous steps of this derivation, go and check out the playlist of calculus of variation and integral equations playlist. Okay, so that you can found on my channel. Okay, yeah, so here in the previous video I explained it till this. That is, you found the value of t. After finding the value of t, you have found all these, right? After finding these, what we have to do is, that is what I'm going to explain in this video. Okay, so here you are writing another one formula, that is the total potential energy. You are using that formula, and in that formula you are going to substitute the values, right? So that is what we are going to do. So here you are writing the formula. This is the formula. Now it is equal to m1g, right, as it is, because we don't have values for that, so write as it is. In the place of y1, you can substitute the value of y1 that you have found in the very beginning of this derivation. So just substitute it and then plus m2g, and in the place of y2, substitute the value of y2 that you have in the very beginning of this derivation. Okay, so here after writing this, what you are doing is just multiply this so that you will get this line, get this term, right? Then also you are multiplying this also so that you will get this step. And after that, what you are doing is you are taking minus GL1 cos theta 1 common from these two terms so that you will get this, and put this minus and write this term as it is. Now you got the value of V. This is the value of V, and using this you are going to find the value of dou V by dou theta 1 and dou V by dou theta 2. Okay, it means you are partially differentiating V with respect to theta 1 first, and here what you are doing is you are partially differentiating this V with respect to theta 2. So what you are doing, so here you are going to partially differentiate with respect to theta 1. So only in the term, if there is theta 1, then you can differentiate. Otherwise, the value for that term without theta 1 will become 0. Is that clear? Okay, that is what we are going to do here. Dou V by dou theta 1 is equal to, here you have theta 1, right? So you have to differentiate this, partially differentiate this, so that you will get minus GL1, right, as it is in V, and then here theta 1, when you differentiate this, you will get minus sine theta 1, and write this value. So this will become 0 because here is no theta 1, right? So that you will get this. Now we are finding dou V by dou theta 2. When you find this, what you happen is, here is no theta 2 values, so this will become 0 when you partially differentiate this with respect to theta 2, but here you can find the theta 2, right? So just differentiate this so that you will get minus m2gl2 cos theta 2. When you differentiate this, you will get minus sine theta 2, so just write it down. So this minus and minus will get cancelled, so that you will get this. Minus and minus will become positive, and you will get this value. Now this is I will say this is the hero of this derivation. The reason is because the reason for finding the reason for finding these dou t by finding the value of t, and using the value of t, we found all these values, and then you used the formula of total potential energy and found the value of capital V, and dou V by dou theta 1, dou V by dou theta 2. All these just because you need all these values to substitute it in this Lagrange's equation. That is the only need of finding all these things. Okay, so you found all these in the previous steps, so you know the values now, so just substitute those values in this form, in this equation. Okay, first you have to memorize this equation. I could say that this equation is the hero that you can see in the unit 2 of calculus of variation and integral equations paper. Okay, let me stop blabbering and let us start start deriving this compound motion of compound pendulum, equation of motion of compound pendulum, right? Okay, let's start. So here just write the equations, and then first you are doing for this. Okay, so first equation 1 implies put d by dt of, in the place of dou t by dou theta 1, just substitute the value that you have found already. I don't want to turn back the paper. Okay, I hope you understand, or I hope you can follow what I'm saying. Minus, put this minus, and in the place of dou t by dou theta 1, just substitute the value, put this plus, and in the place of this, write this value is equal to 0. Now here what you are doing is d by dt of this value, right? So you have to differentiate this. So this is not partially differentiating, so that you have to keep in your mind. So here you don't bother about, you don't look at the, you don't say, you could not say there is no theta 1 term, so I don't differentiate this, that term will become 0. That concept is not going to work out here. Okay, because this is, you are not partially differentiating, you are just differentiating this. So you will get, when you differentiate this, you will get L1 square. So when you differentiate theta 1 dot, it will become theta 1 double dot, and put this m1 plus m2 plus m2 L1 L2. Okay, m2 L1 L2, right? And what you are going to do is you are going to differentiate this in UV format. So that is why write this values and put this bracket. Start the square bracket, and then you are differentiating this in UV format. So you know that, I hope you know that UV format of differentiation. Here what you are doing is you are differentiating this first, so that you will get theta 2 double dot, keep this term as it is, and after putting plus you have to keep this as it is, and you will differentiate this. That is, you have a formula uv dash plus vu dash. Okay, that is what the format of differentiating in UV form, right? So that is the process you are doing here also. You are first differentiating this by keeping this as it is, and then you are differentiating this by keeping this as it is. So that process is happening here. Plus theta 2 dot, you are differentiating this, so that you will get minus sine theta 1 minus theta 2, and after writing this you will differentiate this also. Okay, theta 1 and theta 2 also. At that time you will get theta 1 dot minus theta 2 dot, close the bracket, square bracket, and then write this, multiply this, so it becomes plus m2 this term, and then plus this term is equal to 0. Now what you are doing is you are just in this step what you are doing is you are multiplying this, plus and minus will become minus. That is the only change you are making here. So in the next step what you will do is you will multiply this term, okay, inside, so that you will get the next step that I am going to show you. So you will get this. So from this what you are doing is you will get this, right? So in the next step what you are doing is write these terms as it is in this step, put the minus, and here what you are doing is you are going to multiply this with this theta 1 dot, and then you multiply this with this theta 2 dot. That is what you will do here. Okay, m2 l1 l2 theta 2 dot, and write this theta 1 dot into this value, and then put this minus, then m2 this is then theta 2 dot into this. Okay, that is what, just multiplying, then write this term as it is. And here this is very simple actually. You can understand it by your own, because you are more genius than me, right? So you will take least time than the time I have took to understand these when I got prepared for these. Okay. So here what you're doing, you are just without bracket you are writing. Okay, so multiplying this minus to the terms that they are inside this bracket. That is, you are trying to remove the bracket. To remove this square bracket, what you have to do, just multiply this. You will give this minus to both, right? That process you will do, right? So that is what you are doing. Now you are dividing this with L1, so that you will get this. After dividing, you will get these two terms look similar with but this term will have minus and this term will have plus, so both will get cancelled, so that you will get this. So mark it as equation number 3. So the same process, the same things that you have done for equation number 1, the same thing you are going to do for equation number 2. Okay, so I am not going to explain you that, just I will show you. Okay, so okay, the same process you can understand, because my notes looks very good and you can understand that also. These are the things, these mistakes I have committed when I prepared for it, so don't look at these. Okay, these are wrong. Can you see that? After this step, this is the step, these two terms will get cancelled. So after these two steps get cancelled, what will get, you will get these terms, right? You write the next step without writing these two terms. So to the term, what you're doing is you are dividing that with the m2 l2, so that you will get this. So this is the equation number 4, and this is equation number 3. So this 3 and 4 are the equation of motion of compound pendulum. So here this derivation comes to an end. Very huge, right? But this is simple but huge. Thank you.